Well, in the previous video, we did question 1.3.1. Now in this video, we're going to do question 1.3.2. Question 1.3 says, given f of x is equal to x squared plus 8x plus 16. And in the previous video, we did solve for f of x greater than 0. Now the question says, for which 1.3.2 says, for which values of p will f of x equal to p have two unequal negative roots? All right. I'm gonna write here. Question. Now we're doing question 1.3.2. The question says we need to find the value of p. Okay, if f of x equal to p, will generate two unequal real roots. All right, first of all, let me write f of x is given by f of x was given by x squared plus 8x plus 16. Now that we set f of x is equal to p, this means that f of x will be written like x squared plus 8x plus 16 equal to p. Okay, and if you move the p over, this will be x squared plus 8x plus 16 minus p equal to 0. Now, we need to find the value of p, this p, okay, such that the function f of x generates two real roots. Remember in the previous video, we only had like one real root, one negative real root, but we want two negative real roots unequal, okay? So first of all, let's talk about the condition for having real roots. So now we can have real roots if the discriminant delta is greater than 0. The discriminant itself is given by b squared minus 4ac. Okay. So in this situation, I am going to work out the discriminant. Let's first identify the values of b, a, c. Okay, a, b, c. So a is the coefficient of x squared, which is 1, and then b is the coefficient of x, which is 8, and then c is the coefficient of the constant term, okay, which is so this is a, that b, and all this is c. Okay, a, b, c. C will be 16, the constant term in the equation, 16 minus p. Now we can work out the discriminant. This will be delta will be b squared, which is 8 squared, minus 4a. Excuse me, a is 1. A is 1, and then c is 16 minus p. So it's like 8 squared, which is 64. 64 minus 4 times 16 minus p. And then this is like 64 minus 4 times 16 will make 64. Negative 4 times 16 is negative 64, and negative 4 times negative p will make positive 4p. So now all this we can simplify. The discriminant delta will be equal to 4p. Now, according to the condition, the discriminant must be greater than 0. So 4p must be greater than 0. This means if we divide by 4 both sides, we divide by 4, we divide by 4, we will get p is greater than 0. So this is p must be greater than 0. This is the condition to have real roots. But the question is it's quite precise. It says two unequal real roots. So far, we only have a proof of having real roots. So we can say real roots will be produced if we have like x is equal to negative 8 plus minus square root of the square root of, you know, the quadratic equation, right? Let me first write it. The quadratic equation is given by the solution for the quadratic equation is negative b plus minus square root of b squared minus 4ac okay, all over 2a. So we can say it will generate real roots if we have like negative b plus minus square root of b squared minus 4ac, just a discriminant, which is 4p, okay? So square root of 4p over 2, okay? Because a is just 1. Now, what should be then the condition for having unequal roots? For negative, now, negative roots, excuse me, negative root then. So this will be negative because over here, we have like two solutions. One with the positive and the other with the negative, okay? We have like the negative 8 plus root 4 plus 4p over 2, and then negative 8 must be, let me write it properly, it's like negative 8 like this. It's part of within the bracket, within the fraction line, minus root 4p over 2. We have like these two solutions. Now, root 4p for this part here, we already have a negative value. It's going to be negative because two negative will just generate another negative. So, and then because square root of 4p, regardless of the value of p, because p is positive, so this will be positive also. And then when we put negative in front of it, negative minus negative will always be negative, but the one is a bit here. Okay, we already have like one root here, one negative root here, one negative root over here. But over there, we're not sure to have a negative root. But let's first look at the turning point. If this value of 4p has a value of 8, for instance, 8, then we have 0 over here. If it's less than 8, square root of 4p is less than 8, then we're going to get a negative value. If it's more than 8, we're going to get a positive value, but we want to have negative values. So we're going to set root of 4p lesser than 0, okay? Excuse me, lesser than 8, because if it is 8, we're going to get 0. So it must be lesser than 8, because by 8 is the turning point, okay? So now we're going to write a negative 8, excuse me, square root of 4p lesser than 8. Okay, let me get back in case you didn't get it. I say if root 4p is 8, the opposite sign, because we have 0, 1, we have like a same magnitude but opposite sign, negative 8 plus 8 will make 0. So now if it is lesser than 8, then it's when we can get the negative value. So over here, we need to set square root of 4p lesser than 8. And then if we raise both sides to the power of 2, to the power of 2 and to the power of 2, this will be 16p squared lesser than 64. And then we divide both sides by 16. We get p squared equal to, it must be lesser than, if we raise to the power of 2, over here we will get 4p. 4p, because the power of 2 here we cancel the roots, and then we have only left 4p. So we will divide by 4 instead. We divide by 4, and then this makes p, not p squared, but p lesser than 16. Lesser than 16. Now we have like two conditions here. The first condition, P must be greater than 0. The second condition is P must be less than 16. So greater than 0, less than 16 makes the P in between 0 and 16. So we write the solution must be 0 less than P less than 6. Thank you.